I decided to build a Dodecahedron Infinity Mirror, and I looked at several examples online, but I wasn't too enamoured with them. Okay, I was enamoured with them, that's why I'm building it in the first place, but I thought maybe we could do better. Most of them seem to be held together with a bit of tape or some aluminium extrusion that was custom made, but I can't do that here. Don't have the tools to make that, but I do have a 3D printer, and I have come up with these extrusions that will hold the acrylic at the right angles to make the dodecahedron. It has got lines in it, holes in it to put cables, and I can take a strip of LEDs and stick it on, and hopefully that will all work out. To make gluing them up easier, I've come up with these pieces that allow the extrusions to be stuck together and held in place for glue, and if they don't quite meet up, we can hold them slightly apart and then using some sandpaper file them to the correct angle. These joints are glue holders, also allow for an elastic band to be put on to hold everything in place. Just to hold everything while the glue dries. If that doesn't work, as may not in some cases, there are alternatives such as this. This makes it easier to remove the elastic band because you just plop it off here. Or the alternative is to use something like this. This fits on the outside as well, and then you can just take some normal clamps and just clamp it in place. This is more likely to be useful when you've got some acrylic in one of the channels. Make sure once you've glued it up that the channels for the acrylic are clear of glue, otherwise it won't fit in. Cutting the acrylic sheets, I use one of these to scrape the acrylic to mark the correct size, and although you should be able to break the acrylic cleanly once the scrape is deep enough, I finished it off with one of these, basically a hacksaw blade in a handle, and then sandpaper. I have two possible window films to cover the acrylic once I remove the backing sheets. The standard mirror effect film, or I've got this dichromatic stuff, which I'm not sure gives the correct mirror effect for an infinity mirror, but it is very nice looking. So I don't know which one I'm going to use. Okay, I have put some of the film onto the pentagons, the acrylic pentagons. This is the standard silver film, half reflective film. Looks pretty good. When you see down, you can see the reflection, not too see-through, not too bad. This one is with the chromatic film. More see-through, but look at those colours. That looks good. And what have I done over here? I put two films on the one piece. So you get the best of both worlds. So if I've got enough film, I think this is what I'm going to go for. So I've also been playing about with several glues. Now some of them discoloured the plastic, caused runs because it's so thin, capillary action, and here as well. What I am going to use, I think, is this poly cement or two-part adhesive, epoxy. The LEDs come in rolls 1 metre in length with connectors at both ends. So you need to take the connectors off and then chop it up into strips. Right, here is the base, well, I've called it a crown, the bottom half of the dodecahedron. There would be a top half that's identical to this, and then a bit that goes around the circumference. I've wired up these LEDs, which will then fit around the base. I'm going to take off the vertical bits so that I can connect the power. I don't want to solder them in place until I've got them off the plastic dodecahedron shape, because solder melts at a much higher temperature than the plastic, and I don't want to damage the plastic or drop molten solder onto the acrylic sheet, the mirrored acrylic sheet. So that is part one. Once I've got this wired up, I will try the power, run them as white LEDs and see what power is drained, see if the wires get overly hot. Hoping not. I've wired up these two basically wiring harnesses, thick wire going to thinner wire. So one of these wires will go to the bottom crown, one to the middle circumference, and one to the top crown. And that's how we'll get power to each of those. These fit within one of these strips. Just have to displace them. I could put heat shrink around them, but I think the heat shrink might make it too thick for them to actually fit. I just displace them slightly. Black in first, then red, and then these will come out and go wherever they need to go. So this may look a bit janky. Now I've got the LEDs mounted here, roughly, and none of them are stuck down. I have a hole drilled in one corner where I've got the leads out. The harnesses that I've showed you previously are coming out here. They both go down this one, across and then out. I've got a 6 amp 5 volt power supply, an SP108E LED controller, and now we're going to test it and see what it looks like. Let's see, put in some plugs. So LEDs seem to work. I'm just looking up the app for the 108. It's scanning for the app, or scanning for the SP108 controller. It's found it. Enter, and we can change colour. I'll just put this into the screen. Should we go yellow, purple, so that all works. So you go for white, static, and let's increase the brightness. I don't think we need to go that high, but that will be drawing the 6 amps. And that is far too bright for normal use. I think where we started, which was about 1/3 the brightness, let's see if we can bring the brightness down. For some reason the app didn't really want to. Somewhere around about there would be 1/3, slightly less. Wave, what's wave? Let's go for yellow on a wave. So test the final harness before I install it on the top crown, just making sure all the lights work. Everything looks good. So, right, I'm getting close to setting this up. I have tucked the power leads down inside this extrusion, and I'm going to do the same on this one with the data signal. I want to keep them long just in case I have to open it up again, and I think that will make it easier. Now I need to get gloves on to put the remaining pieces of acrylic onto the frame to avoid fingerprints. I've washed the inside of what I've already done. I've had to use some acetone because I've stuck the lights on with the double-sided tape that's on them. Plus I saw on the internet recommended putting some super glue on 3 points just to hold it in place because the double-sided tape wasn't sufficient, and I have found that as well. Some of the bits I stuck on have come up on the middle, and of course when putting the super glue on I got it on my fingers, and from the fingers onto the foil that's covering the acrylic. So I've washed it off the best I can, and now the next time you see it, it should be a completed dodecahedron. The dodecahedron is assembled. I glued the top crown on using 5-minute epoxy. It's not that strong, so I should be able to dismantle it if I need. I was going to write my own code for it. It's running on an ESP, was it 8266? But a quick search on the internet for Infinity Mirror dodecahedron code, and I came across Albert Barber's Instructables, which had a link to GitHub and his dodecahedron code. Slight modification for this, but it works, as you can see, and is far better than anything I could have written. You'll see that it looks different from different angles because of that was it chromatic film that I used, dichromatic film. But you do certainly get the infinity effect. Oh, that looks brilliant. Now all I need to do is design a stand for it. That's next. This is the Infinity Dodecahedron. I'm just running off software on the SP108E. Just showing you don't need to write complicated software to get some interesting patterns. You can see the infinity effect. I have a new helper piece. Goes in the corners and allows a clamp to be used to hold joints together while the glue dries. I've been using quickset epoxy. Unfortunately it hasn't been strong enough and some of the joints have popped open, so now I've scraped out the old epoxy, put in new slower setting epoxy, and now the clamps are there to hold it while it dries. Okay, this is the case I've come up with. The mains cable coming through here, an on-off switch. I have ventilation holes for the power supply. The ESP8266 is mounted on a little plastic board which slides into grooves, clicks into place. And then there's 3 buttons that are required by Albert Barber's code. One to advance to the next effect. The effects advance automatically, but you can stop that by pressing the middle button, and the bottom buttons for brightness. And if you press the top 2 together, it actually switches off the illuminations altogether. Press them again, switches it back on. I have used brass inserts on the lid, mostly because I bought them for another project and never used them, so I thought that would be quite useful. It allows me to get access again. The dodecahedron connects through these connectors. If I'd left the power leads on the dodecahedron long enough, I wouldn't need this, but there you go. And that's just for convenience. That's it. This pole here is supposedly for strain relief for the mains cable. But the mains cable I've got, well, that was all the DIY store had, and it is quite thick for a light. But it was the only one they had, the smallest one they had. It was 3-core, and I wanted to put the earth on, because the power supply has an earth connection, but it means that it wouldn't fit between the gap there that I left for the mains cable. The 2-core does, but 3-core not. So that's it. There's a hole in the middle because I intend to mount the dodecahedron on its corner. Using some form of mount like that. Let's see if I can get a triangular bit that I haven't used yet. So something like that. This is a floral design for a stand. This is a more industrial design. This is more an Antonium design. And this is the same thing but with a thinner column in the middle. So instead of this one, I've got the thinner one. This project has taken a long time. I started in the middle of 2020 and it's now the middle of 2023. I spent ages planning the shape of the extrusion, trying to get it as thin as possible but still do everything I wanted it to do. Then worrying about the power consumption of the LEDs. Did I need to mount them in heat sinks? Did I need to add ventilation holes to the dodecahedron? In the end, I mostly ignored my concerns and just implemented it to see what would happen. Some imperfections exist with my application of the foil to the acrylic. Either I didn't clean the acrylic well enough, or some dust got stuck to the foils during its application. As I didn't remove the protective plastic on the other side of the acrylic until after I assembled the dodecahedron, I didn't notice until it was too late to do anything about it. I haven't covered how to wire the LED segments. I bought 3 1-meter strips with 100 LEDs per meter and cut them into lengths of 10 LEDs per strip. The top and bottom crowns both use 10 segments, as does the circumference section. All the positive and negative connections are wired together on a section, and then each section is connected to its own wire of the wiring harness. This is to limit the power going through any single segment of LED strip. The data lines of all 30 segments are connected one after the other, in serial in other words. The data in on one is connected to the data out of the previous segment. The order they are wired doesn't really matter, as it's taken care of in the code. In some of the early shots of the dodecahedron operating, you can see that some of the LEDs aren't lighting for some of the effects. This turned out to be because I accidentally deleted a line of code I added to the .h file that defines the LEDs' relationships to each other in Albert's code. That caused 7 LEDs in 3 strips not to light for some effects. The wiring of my dodecahedron is different from Albert's, but I took his wiring diagram and worked out the mapping between the two, and as you can see from these final shots, it worked. Since the video was shot, I have created a TPU bung that fits around the dodecahedron wires as they enter the lid, and when pushed into the lid, it holds the lid and the dodecahedron together. I've also used black epoxy putty to fill in any gaps or imperfections at the joints between the extrusions. The shade of black of the epoxy seems to match perfectly. I hope you enjoyed the video.